Hi, this is a demonstration of the ESD package, and this is part one where we show how we can use it to work with climate station data. And the idea of the ESD package is to make life easy for you. So before you start, you need to need to activate the ESD package, which we run by just writing library ESD, and then it will also it will activate ESD and also activate other packages that are necessary. Then we want to just get some data to work with, some sample data. We use this function called station, and that will fetch data over the internet from a US website. So basically we're getting some precipitation from the a data source called Global Historical Climate Network and daily data, and we want to pick data for a country like, say, Mozambique. And then we want to just examine what the data looks like. So we can write map y and then fun equals nv, for instance, to see what they look like. And new equals false, just to show. The last one is to make sure that it shows up in this window here. Otherwise it can make a new pop-up window. So if you look at this, so here you see the stations. We can also examine it by y. Diagnose just to see where we have missing data. You can see it. Beira here has the biggest diagnose. So here you can see we have missing data after this part, so this is not very good coverage of the data, but we can still just look at it and see what it looks like. So we can use subset here to select one of the stations rather than looking at all of them. We can plot. We can look at what it looks like. Summary y and run that. And it gives like an overview of the data. So the minimum values and the maximum values, number of missing values here, and the mean here, and these are the quantiles. We can plot the data here. So this is what it looks like. We can also plot the annual data as well, so this, when we write annual and fun equals sum, that's annual totals rather than annual mean. Mean is the default here. We can also, let's see if we remove this, this y, let's visualize y in a different way. So it shows the year here, and also like you see the rainfall here, and you can see like you have some bands of missing data here. Another way of selecting data is using select station. We can so this is a meta database that is included in the ESD package. And it's a faster way of searching and finding what data there is. We can have, and then it shows like what the data looks like here. So we can also map the metadata rather before we actually fetch it. So here you have the data, and then when we want to use station, we just write SS like the call to select station. We do not write anything else. So then it just gets 4 data points here. I guess some of these are on top of each other. Now you can see, and then we plot. It's just plots. And then map equals false. So these are the data here, so they are partly overlapping. We can also plot the annual or anomaly. Like that. A final way of getting the data here is using retrieve. So that's when the data is stored as an etcd file. And this is on a local machine here. So this is for Asia. So it reads Asian data, and then we can make a map the data, and we show the maximum values now rather than number values. So here are the data for Asia. So this is just one example. Yeah, finally, I want to show you something. So if I just say wheel, that gives an annual wheel subsets XIS equals 1. So this is the first of these. If you press run that, so here we get a wheel of the precipitation, and you can see that there are different colors here. So the red ones are the recent ones, and blue ones are less recent ones. This is probably not a good example because it was not very long. We can do like X. See how long these data sets are. These are from Global Climate Network, so they're not. So you can see that the first one was very short. So and we can say, okay, what's the number values equals apply X to fun equals NV. So then we say, okay, we want to have X equals subset XIS equals NV equals max NV. Plus X new equals false. So this is it. We can also write plots, and then we can have spell X, and then we have threshold equals 1 millimeter, and then we can, so this is like a plot of the duration of the dry spells and also the long spells there. We can also look at histogram of that. So again, if you zoom in here, you can see the dry spells and the wet spells, and compared to the geometric distribution.